taking this question from the November 2016 grade 12, question 8. In the diagram below, PQRT is a cyclic quadrilateral having RT parallel to QP. The tangent at P meets RT produced at S, and QP is equals to QT, and PTS is equals to 70 degrees. So let's analyze the diagram. We are told that PQ is parallel to TR. In other words, this angle must be 70 degrees as well, because we are going to have alternating angles there, with this line parallel to that line. Okay, and then the tangent at P meets RT produced. So this is a tangent, PS is a tangent, and the angle between a tangent and a chord is equal to the angle subtended by the very same chord in the alternating segment. So it means that P1 is equal to Q1 because of the tan chord theorem. 8.1.1. Give a reason why P2 is equal to 70 degrees. So we are saying that PTS is equal to P2 because of alternating angles, and then we write the parallel lines. So RT is parallel to QP. 8.1.2. Calculate with reasons the sizes of the following. Q1. Okay. T2 is equal to 70 degrees as well. This is because equal chords subtend equal angles. PQ is equals to TQ, we are told. So T2 should be equals to P2. So for A, we're going to say P2 is equals to T2, 70 degrees. And then we'll say equal chords subtend equal angles. And then we just write the chords that are equal. PQ is equals to TQ. In triangle PTQ, P2 plus T2 plus Q1 should be equals to 180 degrees. And this is because of the sum of the angles in a triangle. P2 is 70 degrees, T2 is 70 degrees, Q1. So Q1 is equals to 40 degrees. B, the size of P1. Well, P1 is equals to Q1 because of the tan chord theorem. So P1 should be equals to 40 degrees. Then 8.2. A, B, C are points on the circle having center O. S and T are points on AC and AB respectively, such that OS is perpendicular to AC and OT is perpendicular to AB. AB is equals to 40. So AB is equals to 40, and AC is equals to 48. Well, if a line is drawn from the center of the circle and it is perpendicular to the chord, then it bisects the chord. It means that here I'll have 20 and there I'll have 20. The same applies this side. So here I'm going to have 24 and 24. Calculate AT. So 8.2.1, 80. 80 is equals to 20. And then we'll say the line drawn from center pip to chord. It bisects the chord. And then we'll just say OT is perpendicular to AB. And then 8.2.2. If OS is equals to 7 over 15 multiplied by OT, calculate the radius OA of the circle. OS is equals to 7 over 15 multiplied by OT. So this means that OS over OT should be equals to 7 over 15. OS is 7 and then OT is 15. And now we have this triangle right here. We will say in triangle OAT, and then OA squared is equals to AT squared plus OT squared. This is because of Pythagoras. And then OA squared is equals to AT is 20 squared. OT is 15 squared. Therefore, OA should be equals to, so this is 25. You can even use this triangle OSA, because you have the side in that, so you can find OA. Moving on. Question 9. ABC is a tangent to the circle BFE. So ABC is a tangent. So it means that B1 is equals to X. Because of the tan chord theorem, this angle must be equals to that angle. Okay. And then from C, a straight line is drawn parallel to BF. So DC is parallel to BF. To meet FE produced to meet FE produced at D. Okay. EC and BD are drawn. So EC and BD are drawn. E1 is equals to E2, which is equals to X. And C2 is equals to Y. Okay. So the whole of this angle should be equals to X. Because of corresponding angles, we have an F there. So this angle is equals to that angle. Okay. And then D2 must be equals to the whole of that angle. And this is because of alternating angles. Okay. 9.1.1. Give a reason why each of the following is true. B1 is equals to X. So this is because of the tan chord theorem. 9.1.2. BCD is equals to B1. Well, corresponding angles, and then we just write the parallel lines. DC is parallel to FB. 9.2. Prove that BCDE is a cyclic quadrilateral. Well, yes, it is, because E1 is equals to BCD. Both of them are equals to x. And then we would say, therefore, BCDE is a cyclic quadrilateral. And then we'll say the exterior, because this becomes my cyclic quadrilateral, and that angle is the exterior angle. The exterior angle of a cyclic quad is equal to the interior opposite angle. And then 9.3. Which two other angles are each equals to x? Okay. Let's see. So I already know that BCDE is a cyclic quadrilateral. It means that E2 should be equals to D2 because of angles on the same segment. So E2 is equals to D2, which is equals to x. And the reason is angles on same segment. Okay, and then FBD is equals to D2. We will say D2 is equals to FBD because of alternating angles. DC is parallel to FB. Then 9.4. Prove that B2 is equals to C1. Okay, C1 plus C2 should be equals to x, because we've already said that B1 is equals to the whole of C, which is equals to x. And then C1 plus C2 is y, is equals to x. Therefore, C1 should be equals to x minus y. So this is x minus y. So if we can prove that B2 is equals to x minus y, the two will be equal. Okay. So C2 is equals to B3, which is equals to y, because of angles on same segment. But we know that B2 plus B3 should be equals to x. B2 plus B3 should be equals to x. B2 plus y equals to x. Therefore, B2 should be equals to x minus y. So yes, B2 is equals to cy. This is a proof. You just have to learn the proof from your theory. And then 10.2. In the diagram, HLKF is a cyclic quadrilateral. Sorry. The chords HL and FK are produced to meet at M. The line through F parallel to KL meets MH produced at G. And then MK is equals to X, KF is equals to 2X, ML is Y, and LH is equals to HG. Okay, so we have this line parallel to that one. So it means that this angle is equals to that angle. And the whole of this angle is equals to that angle. And this is simply because of corresponding angles. Okay. 10.2.1. Give a reason why GFM, so it's GFM, so it's GF, so that angle is equals to LKM is equals to this angle. Well, that's because of corresponding angles. Then we'll say corresponding angles because FG is parallel to LK. Then 10.2.2 A. We need to prove that GH is equals to Y. GH. So we need to prove that this length here is equals to Y. Well, let's look at this big triangle. And then you can see that this line is parallel to that one. So we can apply, we will say MK over KF should be equals to. So we are saying MK over KF. And then MK goes with ML. So this will be ML over KF goes with LG. So this LG. And this is because of the line parallel to one side of triangle. KL parallel to FG. MK is X. And then KF, that's 2X. And then ML, that's a Y. And then LG. So this is going to be LG should be equals to 2Y. But you can see that LG is equals to LH plus HG. And we are also told that LH is equals to HG. So LG should be equals to 2 times HG. LG is 2Y. This is 2HG. We'll cancel both sides, the 2. So HG should be equals to a Y. So we have proven. Then B. Let's just clean this up. Prove that triangle MFH is similar to triangle MGF. So triangle MFH, triangle MFH. So this triangle, it must be similar to triangle MGF. So it's similar to this triangle. Okay. Well, in triangle MFH and triangle MGF, well, M is equals to M because it is common. M should be equals to M because it's common. Okay. So I need to prove that F is equals to G, or I need to prove that H is equals to F. If I can do that, then they will be similar. Okay. So L1 is equals to F2 because of exterior angle of cyclic quad. Because I'm told that LKHF is a cyclic quad. Okay. And then let's see. Okay. L1 is equals to G. L1 is equals to G because of corresponding angles. Because LK is parallel to GF. So this means that F2 is equals to G because they are both equals to L1. So this means that HMHF is equals to MFG. This is the third angle of a triangle. So this means that triangle MFH is similar to triangle MGF. See, I need to prove that GF over FH is equals to that. So we just take our triangles and then we take MGF. So we'll create a ratio. You'll say this over that, and that over this is equals to that all over that. So we say MF over MG is equals to FH over GF is equals to MH over MF. And then we just check for the sides that we do have. And then MF I do have, it's 3x. MG I do have as well, it's 3y. Okay, and then I am looking for GF over FH. So I'm looking for GF over FH. So we'll say GF over FH is equal, so GF is equals to MG all over MF. What is MG? This is Y and that's Y. MG should be equals to 3y over, and then MF that is equals to 3x. Now this means that I've done something wrong, so let's just quickly double check. MF, that is going to be 3x. Okay, let's use the other side. MH is 2y, and then MF, that's 3x. So let's just use the other part. FH over GF is equals to MH all over MF. And then we'll just say similar triangles. What is FH? That is what I'm looking for. Okay, so I'll just turn this around. This is going to be GF over FH. So MF is equal, must be in proportion with GH. So what is GH? GH. What is MF is 3x. So this is 3x. And then FH, then MH is 2y. So MH is this length, which is 2y. And then MF is this length, which is x plus 2x. So that is equals to 3x. 10.2.3. Show that y over x is equals to square root 3 over 2. So I'm just going to take the other side that I didn't use. So this is going to be GF over FH. And then GF goes with MG all over MF. This is 3x over 2y there. And then MG I am getting, that's a 3y because it's y plus y plus y. So that's a 3. And then MF, that's a 3x. So here I'm getting 3. This is 9x squared, which is equals to 6y squared. And then I need to have the y on top. So this is y over x, y squared. So this is 9 over 6. This is equals to 9 over 6. That gives me 3 over 2. And I'm just going to square both sides. So this is 3 over 2 squared.